Over the past couple of terms, we built out and finished a live, working build of the Teach Safely website. The website sponsor has been developing a number of safety training courses aimed to teach high school students how to safely use dangerous construction tools like bandsaws, ankle grinders, and drill presses. Each safety lesson consists of a high-quality video, a downloadable worksheet, and a safety quiz. The goal of our Teach Safely website is to provide a completely free and easy-to-use way for high school shop teachers to administer this training material to their students. Our website hosts the videos and worksheets, administers and automatically grades the quizzes, and presents each student's results to their teacher. We also built an interface to make it really easy for the project sponsor to upload new safety lessons, and we set the project up so that future PSU capstone teams can continue development on it. Let's start with a demo of the teacher portal.
Hello, my name is Arturo Bravo, and this is the Teach Safely website homepage. I'm going to show you what it's like if I was a construction teacher preparing for the fall term. So first, I will go to the teacher page and head to my portal. Here I can create a class, say Woodworking 101, and I'll just set that for the fall. And then if I click create, it will show up right here. And then if I click this, it can take me right here to the class page. Right here, I can manage the lessons. Clearly, I haven't added any yet. And right here, I can see what the lessons consist of. It shows me the video. I can view it. I can see the description, what the lesson's about. I can get a sample of the quiz questions that come included with the lesson. So then I will add the circular saw safety and this band safety. This class code up here, this is what I would send to my students so they can access this class and access the lessons in it. And when students finish their lesson, their results will show up here. Their student name, their email, their quiz scores, and if they have completed the hands-on exercise.
Be demoing as a student. We're going to go over here and enter in our class code. And this is just general class information, end date, instructor. And we can see our lessons down here. So we're just going to select the first one. Here we're given the option to download the worksheet if we want to use that to follow along. It's just a PDF file. So we're going to continue on to the video, and we can't continue on until we have watched the whole video. So for our purposes, I'm just going to skip ahead.
Push direct pressure in line with the blade. Always have your hands to the side.
Okay. And now we're just going to fill in some information for our quiz attempt. Alright. Completed the course, and we can return back to the homepage here. And that is it.
Hi, this is Michael, and I'll be demoing the admin portal. Our sponsor is continuing to develop new videos and training content, so we built an admin portal so that they can use to upload their new material as it gets finished. I'll be demoing how that process works. Currently, we are on the admin portal. Let's start by creating a new lesson. Let's first give it a lesson name. Here we can do this. Now let's give it some descriptions. And lastly, we can give it a video, or attach a video. Now we can continue on to uploading some files, some lesson files. Here we will add a worksheet PDF. Let's use this one. And we can also add a lesson thumbnail. That succeeded. And finally, we'll set up the lesson quiz. And that's it, the lesson has been created. As you can see, it shows up in the lesson directory, and teachers can now view it and add it to their classes. This should make it really easy for our sponsor to continue creating lessons and adding them to the website.
Let's talk a little bit about what exactly our task was. We were given a prototype of the website along with some prototype videos and quizzes. So we had an existing CSS file, some mockups of the student portal, some cloud tables, and a few cloud functions. As far as scope is concerned, a number of states across the Pacific Northwest have already requested to start using our sponsor's training material in their high schools as soon as it is ready. But after some negotiation with our sponsor, we decided to just focus on high school shop classes in Oregon for now. This means that we need the website to be able to support 80,000 students or 500,000 lesson attempts each year. Finally, we also decided to make the Teach Safely website a continuing capstone project for future capstone teams to improve and build on. This means that we had 4 distinct user groups we had to consider: high school shop teachers, high school students, the website administrators who create and upload new lesson material, and the future capstone teams who will continue to work on the website. So let's talk about a few of the big things that we worked hard to do on the website. We took the prototype we were given and converted it into a minimum viable product. We used AWS to set up a high-quality teacher and admin account solution. We migrated the website source code from JavaScript to TypeScript, and we set up staging and offline testing for the website. Diving a little more into the first big thing, calling it a minimum viable product is a little misleading. It's minimal in that we forewent adding a bunch of fancy features and instead focused on making the core of the website not only work, but work well. We added loading screens and tooltips and kept the UI really clean, all of which we think are really important, especially because a lot of our audience doesn't have as much experience with technology. And we really wanted to make sure the website was as intuitive for them to use as possible.
A major component we added to build out the website was to allow for teachers and administrators to be able to sign up for an account with all the features many would come to expect on the Teach Safely website. Doing this enables teachers to create classes with tailored lessons that are tied to their account based on their individual course needs, and for administrators to more easily create or edit lessons from a user-friendly interface. We used Amazon Cognito to implement the account features, which gave a scalable solution that provides adequate standards-based authentication, encryption, access control, and overall security. This out-of-the-box solution allowed for more overall productivity in building the site, and less time spent hassling with other third-party options or possibly having to create our own.
In addition to working on features for students and teachers, we put some time into making the source code easier to work with for ourselves and future capstone teams. One of the big improvements we made was migrating the code base to TypeScript. This is really helpful because TypeScript allows for strong typing, which reduces overall bugs, speeds up development time, and makes communicating between different parts of the project easier for developers.
A major part of the work we did was doing the groundwork for staging and offline testing. We felt staging was a necessary part of any substantial project which has many different components to it and potentially teams working on it. This enabled each team to test their own functionality in an isolated online AWS environment, and in the future it could enable more robust quality assurance to be done without disturbing the data that exists in other stage environments. Being able to test offline without deploying to a stage was also necessary because deploying to a stage takes a prohibitively long time. We solved the staging and testing problem with a combination of special plugins for the serverless framework, which emulated AWS services on our local machines, and also a custom deployment script. The deployment script uses the AWS command line interface to gather information that the front end and back end need, write that information to configuration files, then automatically deploy the back end, followed by the front end, and then automatically launching the front end website in a web browser. And that created a faster and seamless testing experience for us.
Some other smaller features of the website. We'll talk more about this later, but we found a way for students to use the website without having to set up and manage their own accounts. The website automatically grades and submits quizzes. We put in a bit of work to add extra validation to our HTML forms and make sure they look really good. We also did some research into different storage solutions and tried to bring hosting costs down as low as possible. And finally, there are a bunch of features that we didn't get the chance to add, but that we hope future Capstone teams will. Currently, the website is only targeted at high schools, but we'd like to see a business-facing side get built as well. Our sponsor would also like to build a way to verify teachers, which would allow them to certify students who finish their tool safety lessons. We think future teams could implement more and more advanced spam prevention. We'd like to see the website undergo some heavy stress tests to make sure it can handle even bigger loads. We also think the future teams can improve developer onboarding, offline caching, and polish off the website's UI. Let's transition now and talk about how we approach this project, starting with the architecture.
The main characteristics of the architecture behind this project involve Amazon Web Services for the backend and Vue.js for the front end. In terms of the backend, there are 4 notable AWS services at play: DynamoDB, S3, Lambda, and API Gateway. The 2 former are used for storing resources. DynamoDB stores structured data in a NoSQL database, data such as lists of classes, lessons, and teachers. S3, on the other hand, is good for large binary unstructured data, therefore it is used to store quiz and lesson content. The functionality of this project depends on AWS Lambda, a compute service that runs code without provisioning or managing servers. Lambda runs functions only when needed and scales automatically, from a few requests per day to thousands per second. Additionally, the Amazon API Gateway is used to create HTTP endpoints to trigger these Lambda functions. This system allows us to serve traffic over the internet reliably and securely due to the included authentication controls. These services are used in conjunction with the serverless framework, which is a CLI that offers structure, automation, and best practices out of the box. The serverless framework not only deploys our Lambda functions and API endpoints, but it also deploys the aforementioned resources, components that our functions depend on. That's the general overview of how the backend works and interacts with the frontend. The frontend portion of this project utilizes Vue.js, a JavaScript framework for building user interfaces. Vue allows the users, such as teachers and students, to interact with the respective interfaces. The teacher portal allows teachers to access lessons, create classes, and manage student records. Students can interact with their classes, which in turn updates their records, and so on. All the while, the front-end utility seamlessly integrates with the AWS services we talked about earlier.
We ended up falling into a 3-phase development approach. We spent the first month and a half or so mainly focused on training and improving the dev environment. After that, we split up into 3 teams, one working on the teacher portal, another on the student portal, and the third on the admin portal. Initially, we planned on incrementally merging each of these branches throughout the project, but we ended up developing all 3 of them individually and then merging them at the end. In the end, I did a little bit of everything, but most notably, helped try to organize everyone and did a bunch of research to find the optimal storage solution configuration. Arturo spearheaded the teacher portal front end. Jared worked on staging and the admin portal backend. Oh, and Jared gets special thanks for helping manage the final merge while I was sick and trying to finish off this presentation. Elena worked on staging and the teacher backend. Travis helped with the TypeScript migration and figured out how to set up AWS Cognito. Michael built the admin portal front end, and Dima helped with the TypeScript migration and worked on the student backend. We had a really good team, and we were able to account for most hurdles before they happened. But there were a few things that we had to work through. It ended up taking us longer to train everyone how to use our tech stack than we initially expected. This wasn't a big deal. We just had to allot a little extra time to training. It turns out responsibly managing users' data takes quite a bit of work, especially when dealing with minors' data. We ended up just trying to store as little data as possible to limit the complexity of the website and our sponsor's liability. This website ended up being more complex than we expected, and just getting all the pieces working and working together took a lot longer than we expected. If we had to do this all over, I would have waited a little longer to start on the admin portal and put all our resources into just getting the teacher and student portals working. We learned a lot working on this project. Like, DynamoDB is a lot cheaper than you'd think it'd be.
I learned how to use Vue from working in this project for the last 6 months.
The 2 main lessons I learned are just how many different technologies are out there for me to learn, and also that I really should be asking more questions instead of trying to find all the answers by myself.
My main takeaway from the last 6 months is the importance of planning and organization, especially when you're working with a team of half a dozen people. It's important to know what needs to be done and how everyone's going to go about doing it.
A lesson that I've learned is the true amount of communication needed between team members. It's obvious that communication is needed, but by being split into front-end and back-end teams, it really brought to light how much each team relies on each other.
Lessons I've learned from working on the project would definitely be to communicate more and ask more questions to avoid the needless pain of trying to find answers to something that somebody else likely already knew.
Thank you to everyone on the team. You are all really good at what you do, and we're all willing to just jump in and do whatever needed to be done. I've really enjoyed getting to work with you, and I'm glad I got such a great team. Thank you to Joe for bringing us a great project and giving us the tools and freedom to approach it however we thought was best.